Hello everyone, welcome to our video series on data science using Python. In this video, we are going to see about the Seaborn library. So this video is the second part of the data visualization. So we are going to look after some plots, and that plots are scatter plot, then histogram, bar plot, box and whiskers plot, and then we will see the pairwise plots. So let's start with a brief introduction on the Seaborn library. Now, Seaborn. It is a Python library which is used for data visualization. Okay. And you can see it also I have written that Seaborn is a Python data visualization library based on Matplotlib. And it provides a high level interface for drawing attractive and informative statistical graphics. Now, one more thing that you guys should know about the Seaborn that Seaborn is built on the top of Matplotlib. And Matplotlib is the fundamental data visualization library in Python, and Seaborn is built on the top of that. Means Seaborn use the fundamental concepts of Matplotlib also. Okay, so with that thing, we can apply some methods of Matplotlib also in our Seaborn. Means with Seaborn, we can apply some methods of Matplotlib also. So we'll see now. Let's just start with the scatter plot. That how we can create this scatter plot with the use of the C1 library. So first of all, let's start with importing our all necessary libraries. So we will import first pandas as PD, then we'll import NumPy for some mathematical operations, and then we'll import matplotlib.pyplot. So we will import this as PLT, and then we will import our C1. So, and we'll give an alias name to C1 as SNS. So So we have successfully imported our libraries. Now let's just load our data. Okay, so now we have successfully loaded our dataset to data.csv. Okay, by using this parameters index call, which will make the by default indexing with 0. Then we have given the NA values, means the special characters which were present in our dataset. We are converting them to none values. And then we are printing the save to check how many rows and columns are there. Okay. Now what we are going to do for making it a perfect dataset, we are going to remove all the none values. So for that, we will use our drop NA method. And in this, we'll specify the axis in row. And then we'll use the parameter in place true so that all the changes should get affected in our data frame. And let's just print our df.saves to check the save now. So now you can see the difference between the save after using the method drop NA. The rows have been reduced from 1436 to 1096, and colors are the same. Now let's just create the scatter plot. So we are going to create the scatter plot for price versus age. So for that, we will use the sns.set method first to set the background. So by default, this set method take dark grid. You can set it to white grid also. So we'll keep it in by default mode only. So we are going to create an age and price. So we'll mention the X and Y. Then we have to define the data. So our data is on the DF dataset. Now let's just run our cell. So this is the plot, the scatter plot, which we have got the age and price. As you can see in the x-axis, there is age in months and the price is there. And you can see with the increase in age, there is a decrease in prices. So most of the values are between 50 and 80. Means most of the cars whose age are in between 50 and 80 months, so they have less prices. Okay. And the cars which are between 0 to 10 months, they have the highest prices. Okay. Now you can see a line here. That line is called regression fit line. Okay. That shows the incline of the plot. Okay. Inclination of the plot. So by default, in this reg plot, it is true. So you can make it false also. Means if you don't want that plot, so what you can do, you can use this parameter fit underscore reg. And this you have to do it false here. So after that, you'll not get that line. Okay. You'll not get that regression fit line. Okay. Then there is one more thing. What you can do, you can see these dots, blue dots in our plot, in our window. So now, if you want to change these dots to some different symbol, so what you can do means from this circle disk dots, what you can do, you can change it to an asterisk using a parameter that is called as marker. So in this marker, you will specify, suppose we want to change it to an asterisk. So you just have to write the particular symbol inside the single quotes or double quotes, and then you have to run the cell. So now you will see instead of that dots or circles, small circles, you can say, you will see the asterisks. Okay. So this is the thing which you can use. Okay. Now we have seen the scatter plot of age and price. Okay. Now we will see the scatter plot of price versus age by fuel type. Okay. With the help of fuel type. So for doing that, first of all, we have to just add one more plot. So what we're going to do in this only, we will specify one more plot, that is LM plot. Okay. In this LM plot, we'll mention all these datas, the x-axis, the y-axis, and the fit rate false. Then there is a parameter that is called as hue, HUE. Okay, which is used to include another variable to show the fuel types of the categories. Okay, which will be used to show another variable. And in our case, we have to add the fuel type. So what you are going to do, we will just add this parameter hue and we'll specify the name of our next variable, which we're going to add. So that is fuel type. Okay. And then there is one more parameter, legend equals true. Actually, it is pronounced as legends. Legends equals true. So let's just do what? Let's just execute our cell now. And let's just see. So now you'll get one more plot. One is the scatter plot and one is this plot. This is also the plot means same, but if you'll see the dots has different colors and that different colors are for the fuel types. And in the fuel types, we already know that there is diesel, petrol, and CNG, which is a categorical type. So you can see that the diesel is in uh, blue color, the petrol is getting denoted with the orange, and CNG is being denoted with the green color. So these uh, means the things which you can see here, my on my arrow, the symbols representing the colors. Okay, the colors means the dots colors representing that it is diesel, petrol, and CNG. That is we are getting using this legend equals true. If you make it false, so now we are not going to see that. Okay, that representation of the colors, the dots. So that is also very necessary. So you can make it true. Now you can add one more thing here. That is the color palettes. Okay. So for that, you have to use one more parameter that is palette. And in this palette, you have to just, there are set of colors. So suppose if you have to use set one, so you write set one, then there is one set two also. So you have to just write the sets. So now you will see the change in colors because it is, we have specified the color palettes explicitly using the palette parameter. And in that we have opt the set one. So now what we can do, you can see in the legends, diesel is being represented with red color, petrol is being represented with the blue, sky blue, you can say, and then green with CNG. Okay. So now we are getting the price versus age scatter plot, but by differences in the fuel type. Means we are getting the fuel type also. Okay. Now this was the scatter plot. Let's just look out the at the histogram. Okay. Okay. So we will create a histogram. Okay. So for creating a histogram with the C1 library, there is a function called histplot. In that function, we are going to create the histoplot for the age. So we'll mention the age and then let's execute the cell. So you can see we are getting the histogram of the variations for the age with the count. Means in the y-axis, we are getting the counts with the frequencies of age. So as you can see, the cars values from 0 to 10 are this much, from 10 to 20. Okay. Now, this histogram is without the kernel density estimate. So if you want to print the kernel density estimate also, so for that, what you have to do, you have to use a parameter for that, and that parameter is KDE, density estimate, and you have to make it true. So when you'll make it true, so you will see a line which is touching all the top bars, means all the top of the bars, and then you can see it is just going down. So it is the means for each bar, it is representing the means the values the kernel density. So if you want this line, then you have to use this parameter and then you have to make it true. Now, there is one more thing. You can see in the normal plot when we have not specified the beans. Beans means that we have not specified the bars, that how many bars we want. So it has taken by default some values. How many we want? Approx 12 bars. Okay, it has taken automatically. Now you can explicitly define the bars also by using a parameter called beans. So what you can do, you can just and you have to just give the value that how many beans you want. Beans means the bars. The rectangular bars you can see that means the beans. So how many beans you want, you can also describe it explicitly using this beans parameter. So now you will get only 5 beans, okay? And with the age and the count of that, okay? Now let's move to the next plot, that is the bar plot. Okay. So the bar plot, we are going to see the frequency distribution of the fuel types of the cars. So for that, we are going to use the SNS, the C1 library, and in this we are going to use the count plot, okay? Because we want the frequency distribution of the fuel types of the cars. Means we want that the fuel types, we should get the count of each categorical value present in our fuel type variable. So for that, we are going to use the count plot. In this, on the X, we are going to specify the column name, fuel type, and then we'll specify the data, which is DF. So you can see we are getting a count plot with diesels, petrol, and CNG, and these three are in different colors. So as you can see, comparatively, this petrol has more, means the vehicles with petrol fuel type is more in comparison to the diesel and CNG ones. And CNG has the least. Okay. Now we see the grouped bar plot of the fuel type and the automatic. Means we are going to see the bar plots only of the fuel types, but with the automatics. Means we will just categorize each value of the fuel type. Means we'll categorize the diesel also with automatic, that how many diesel vehicles are there with with the manual gearbox and with the automatic gearbox. Okay. So now for that, what you can do, we have to just simply use SNS or count plot. And in this count plot, first we'll mention the X. So that is fuel type. Then we have to mention the Y. Okay. We have to use the hue. And in the hue, we'll mention automatic. And then we have to specify our data. So our data is the TF data set. Let's execute the cell. Okay, so there is an error, but we have got our plot also. And that plot is, as you can see, that in diesel and CNG, as we already know that there are no automatic cars in diesel and CNG fuel types. But in petrol, you can see the differences, that the blue color is representing the cars for the manual gearbox, and the orange bar is representing the cars with automatic gearbox. So this is how you can create the group bar plot for the fuel type and the automatic. Means these two types of variables using the count plot. Okay. Now let's just look at the box and the whiskers plot. So we are going to look out the box and the whiskers plot for the numerical values. Means for the numerical variable first. So let's just look at that how we are going to create it. And as we already know that box and whiskers plot returns means gives us, means the data is represented, which is which is summarized as five values. Means it just returns five number summary. First it returns the lowest value, then the highest value, means the lowest range and the highest range, and then it returns the first quartile, second quartile, which is 50%, which is also known as the median, and then the 75%, means the third quartile. So let's just look at that. Let's just look at that. So then there is SNS dot box plot, and we are going to look out for the price. Okay. So we are going to create the box and whiskers plots of price. Okay. So let's just create that. The function which is used for the box and whiskers plot in SNS library is box plot. Okay. Now you can see it is returning a plot like this. So let's just look out each value. As I have already said, it just gives us an interpretation of the five number summary. The lowest, the highest, and then the first quartile, second quartile, and the third quartile. So let's just look at each of the values. Okay. So you can see this horizontal line here and the bottom. So this line represents the lowest range. Okay. Or you can see the lowest value. So which is at the 5,000. So this represents the lowest value. Then you can see, and then at the top, you can see this horizontal line. This represents the highest value. Okay. Which is nearly 17,000 approx. Okay. Then if you'll go from the bottom, if you'll go upwards, then you will see one more line. Okay. First of all, there is a box. Then you can see a first line. So this box represents the quartile for 25%. Middle one represents the 50%. And then the third one represents the 75%. So, and they are also known as first quartile, second quartile, and third quartile. Now, the first line which you can see, it is for the 25%. So that value is, means the 25% of the price is approx this, it is approx 8,500. Okay. Then the 50% values are approx the 10,000, and the 75% values are at the approx 13,500. Now, this 50% value, as we know that the median is also called as the uh, half. So it is also called as the median, means median value. The 50%, the second quartile, it's also known as the median value. Okay. Now, this was the box and whiskers plots. Now, you can see some points here. Okay. On the top of the, means the, on the, at the top of the horizontal line over this line. These are some quartiles. I mean, these are some outliers. Okay. Now, what do you mean by the outliers? Outliers means the values which are extreme highest. Okay. Now, these outliers could be at the bottom also. So if they are at the bottom, then means they are extreme lowest values. And when they are at the highest, means on the the top of this horizontal line, then you can say that it is the highest outliers. Okay. The highest extreme outliers means highest extreme values. So the values greater than which are greater than the this highest value by 1.5x. So that values come to the extreme highest values. Okay. So these are the outliers for the price, which doesn't come inside the range. Okay. On that particular average range, they doesn't come. They are the extreme highest values. That's why they are on the top. Okay. Now let's just look at the Bosc and Vix's plot for numerical and categorical variable together. So for that, what you have to do, in the previous one, we have only specified the price. Now what we are going to do, now we'll specify, we will take one categorical variable and one numerical variable is price. So we will take one variable fuel type. So let's just take SNS dot box plot x equals df. Then let us give the fuel type. Then in the y, we are going to define the price. Okay. And now you will see three, means in single window, we'll see three viscous plots for each category by and with the price. With the price, we'll see three viscous plots. Okay. With the three different categories, which are diesel, petrol, and CNG. So now you can see that lowest and the highest value is in is present in diesel only. Because the diesel has only the most lowest and the highest range. Then if you come to the petrol, so then the petrol and CNG has the lowest range same, but the highest range is more of the petrols in comparison to the CNG. Now, the first quartile of the diesel is approx 7,000. For petrol, it is approx 8.5, and for the CNG, it is 8. Then you can see the median value also, which is for the diesel, it is approx the 9,000. Okay, 9,000 to 10,000 between that. Then you can see for petrol, the median value is 10,000, and for CNG, it is approx it's just touching the 9,000. Okay, then so on. You can see now if you see the outliers, then also you can see that the most extremist uh, values for the price is on the diesel only, as you can see, but they are in less amount, in less quantity in comparison with the petrols. As you can see in the petrols, the outliers are more, means the quantity of the outliers are more, but they are in not that extremist in comparison to the diesel one. As you can see, the diesel one has crossed the 30,000. Means the cars which are of the diesel fuel type are more than the 30,000 price. Okay. And the CNG have less, or you can say that no outliers in the CNG. Okay. So this was the whiskers plot for the numerical and the categorical. Now we are going to create a grouped box and whiskers plot of price versus fuel type and automatic. Okay. So we are going to create a group box. So now we know that we can give x and y axes, but now we have to give automatic also. So for giving the automatic, as we already know in the previous scatter plots also, that we have to use the hue parameter. So that hue parameter will be used here also to give another variable. So simply we are going to do what? We'll mention the x and the y, and then we'll mention the hue. So now we will see for diesel and CNG, if you notice, so we already know that for diesel and CNG, there were no automatic cars. Okay. So that's why there is no plot, means there is no viscous plots for diesel and CNG. But for petrol, there was manual gearboxes also and the automatic gearboxes available. So that's why in petrol we can see that there are two plots, okay, given. Now, if you'll notice at the plot, there is a legend given that for automatic, the name of the variable, and then it has given that color, it has mentioned the color with the category type. Means in the automatic, there were only 0 and 1 values. Okay. So 0 represents that it has a manual gearbox, and 1 represents that it has automatic gearbox. So this orange color is for the automatic, and this plot, the left hand side plot for the petrol is for the manual gearbox. Okay. So now let's just look at these plots one by one. So first of all, you can look at this manual gearboxes cars. So if you'll see, the quantity is more in this. Okay. Now if you'll see the range of this value, so the lowest value is in present in the petrol manual type. Okay. Which is approx near to, means it is 5,000, and the value lowest for the automatic gearbox is approx 6,000. Then if you'll see, the highest value for the manual gearbox fuel type petrol is approx, so it is 16,000 or 16,000 and half. But it is more for the automatic one. For the automatic petrol type vehicles, the highest value is approx 19,000. Okay. And then there are the quartiles, as you can see, the 75% is also greater because of the highest range. This quartiles are also for the automatic are more in comparison to the manual ones. Now, if you focus on the outliers for these two plots, so you can see that because of the quantity, means the quantity is more in the manual type. So that's why you can see the outliers are more in on the manual one, and they are less in the automatic gearboxes. Okay. Now we will see uh, plot, means now we are going to plot the box and whiskers plot and the histogram both on the same window. Okay, both on the same window. So for that, first of all, we have to use a method which is present in the matplotlib library. That method name is subplots. So how we are going to use that? Let's just look at that. So first of all, we'll specify the figure. Then we'll take a tuple and we'll create axes for both of the plots. So now we'll create an axis for the blocks, and then we'll create one more axis for the histogram. Then we will use a method called subplot, okay, from the matplotlib library. And in that, we'll specify first two, which is saying that we are going to create two subplots. Then we'll use a grid spec parameter. And in that, we are going to specify the height ratios, and we'll specify these height ratios inside a tuple. So now, one more thing is here that the addition of these both means both the ratios should be 1. Okay. So I have given 15 and 85. So 15 is for the box axis and 0.85 is for the histogram. Okay. Now, one by one, we will create both of the plots. So let's create the box plot first. So let's make it simple only. So we'll just create for the price. Okay. And then we have to mention the axis also. So for that, we will use the axis parameter, and then we'll specify the axis which we have created for this axis box plot. Then we'll create the hist plot. Again, we'll specify the axis here also, which is the axis attribute AX. Okay, so now you can see a histogram and a viscous plot also. But the viscous plot is very, means we cannot see it clearly. So we have to increase the size of it. So let's make it 50-50. Okay, so now you will see in one window how we just parted into two, and then we printed, means we got the output of the box plot also and histogram also in one single window. Okay, now let's just look at the pairwise plots. That what are these pairwise plots? So these pairwise plots, which is used to plot pairwise relations in a relationships in a data set. Okay, means it will take all the variable names uh, in the y-axis and then the x-axis, and for each of the rows, it will just define you uh, the proper, means according to the correlations between those variables, it will give you the particular plot. Okay, and we are going to create the scatter plots for the joint relationships and histogram for the univariate distributions. Okay, joint relationships means suppose if we are getting the plot for the price and price, so then it will create the histograms. So let's just look how we can create it. So for creating it, first of all, we have to use the method called pair plot. Okay, in this pair plot, we'll mention our data set pair, then we'll mention the kind. So in this kind, we'll mention the scatter. We want the scatter ones, and then the hue. For adding one more, we'll add the hue type, and then let's just use the plt dot show for so that the plot should get printed in more convenient and more in an interactive way. So yeah, it's just taking time. Let's just wait for it. Okay, so now you can see we have got our plot. Okay, and you can see that we have got multiple plots. So let's understand that how we have got these multiple plots. Okay, now first of all, let's start with the bottom. So from the bottom, you can see the x-axis and the y-axis. So let's just first look at the x-axis. So in the x-axis, there is first price, then A's, then kilometer, HP means so horsepower, metallic color, automatic, CC, and weight. Okay, then let's look at the y-axis. So let's look at the y-axis from the top to bottom. So just like the x-axis, if you start with the top to the bottom of the y-axis, you will see price, age, kilometer, horsepower, metallic color, automatic, cc, and weight. Weight is at the last, and the price is at the top. So that is the thing. Means each plot is representing the correlation between these two values. Okay. So if you'll see in this column, there is price, and in this row, the topmost row, there is price. So the price and price column will be the column for the histogram. Okay. So on, you can see the top second column is for age, and from here also the top means the second row means the row and the column for the age is also a histogram. Then for kilometer and kilometer is also an histogram. Means all the for the joint relationships, it will represent with a histogram. Okay. As you can see at the end, it is for weight and weight. So it is also a histogram. And then for the rest of the values, it is giving us the scatter plots. Okay. So now let's just look at this scatter plot for the price and the age. So as you can see that with the increasing age, we are getting less prices. Means if the age increase means age is more of a particular vehicle, so the price is less of that vehicle. Okay. Then you can look at the price and the kilometer. This plot, the the vehicle which has traveled more, the price of that vehicle is less. So you can see the highest prices for the vehicles which have traveled the less. Okay. Then you can see these plots which has no relations. Okay. So this is the pairwise plots. Okay. Based on the correlation of each variable with the another, it is giving us the plots. Okay. And because we have mentioned the kind equals scatter, so it is means most of the values are getting in scatter plots, and only the values which are joint relation means the price and price, age and age, that type of values are getting in the histograms. Okay. So I hope this video was very helpful for you guys. Thanks for watching the video. We'll see you in the